Hello everyone. In this session, we are going to do the question number 10 to question number 15 of exercise 21E of the chapter Trigonometrical Identities from the textbook Concise Mathematics by Selina Publications for class 10. So let's begin with the questions now. But before that, in case you want to refer to the answers of the previous exercises, then the link is getting displayed on the screen right now. So let's begin with question number 10. Prove that the first part is 1 divided by sine A minus cos A minus 1 divided by sine A plus cos A is equal to 2 cos A divided by 2 sine square A minus 1. So here we will begin with our left hand side, that is equal to 1 divided by sine A minus cos A minus 1 divided by sine A plus cos A. So here first we will find out the LCM, which will be the product of the denominators. So it will become sine A minus cos A into sine A plus cos A. Now the numerator here will become sine A plus cos A, and the numerator here will become sine A plus cos A. Now here sine A and minus sine A will get cancelled out. We are left with 2 cos A in the numerator, and the denominator is of the form A minus B into A plus B, which is equal to A square minus B square. So this can be written as sine square A minus cos square A. Now we will write the cos square A in the denominator in terms of sine square A as so here we are changing cos square A in form of sine square as 1 minus sine square A. This is by the trigonometric identity that sine square theta plus cos square theta is equal to 1. Therefore, cos square theta will be equal to 1 minus square theta. Now, we will add the sine square A in the denominator. So, this will become 2 sine square A minus 1, and this is equal to the right hand side, and hence we have proved that the left hand side and the right hand side are equal. The second part of the question is we have to prove that cot square A divided by cosec A minus 1 is equal to cosec A. So we will begin again with the left hand side. Now this can be written as cosec A minus 1. Here we have taken the LCM of cosec A minus 1 and 1. So the numerator will become cot square A minus cosec A plus 1. Now cot square A plus 1 is equal to cosec square A. So this can be written as cosec square A minus cosec A, and this is divided by cosec A minus 1. Now this is because cot square theta plus 1 is equal to cosec square theta, and we have applied the trigonometric identity here. Now we can take cosec A common in the numerator. So this will become cosec A. Cosec A will be in the bracket minus 1 divided by cosec A minus 1. Now the brackets will get cancelled out in the numerator and denominator, and we are left with cosec A, and this is equal to the right hand side, and hence we have proved that the left side and the right hand side are equal. The next question is we have to prove that cos A divided by 1 plus sin A is equal to sec A minus tan A. So we will begin with the left hand side. Now here in the left hand side we are going to multiply both the numerator and denominator with 1 minus sin A. Now the numerator will become cos A into 1 minus sin A, and the denominator is of the form 1 plus sin A into 1 minus sin A, which is equal to A plus B into A minus B. So we will apply the formula, and it will become 1 minus sin square A in the denominator. Now we know that 1 minus sin square A is equal to cos square A, because sin square theta plus cos square theta is equal to 1. Therefore, 1 minus sine square theta is equal to cos square theta. Now, cos A in the numerator will get cancelled out with the cos square A in the denominator. So, here it will become cos A in the numerator now, and this will become 1 minus sine A divided by cos A. Now, we will divide it individually. So, this will become 1 divided by cos A minus sine A divided by cos A. 1 divided by cos A is equal to sec A, and sin A upon cos A is equal to tan A, and this is equal to the right hand side. Hence, we have proved that the left hand side and the right hand side are equal. So, let's begin with the question number 4. This is cos A into 1 plus cot A plus sin A into 1 plus tan A. We have to prove this is equal to sec A plus cosec A. Now, we will begin with the left hand side, and we will first write cot A and tan A in the form of sin and cos. So, this can be written as cos A into 1 plus cos A divided by sin A plus sin A into 1 plus sin A divided by cos A. Now, this is because cot A is equal to cos A divided by sin A, and tan A is equal to sin A by cos A. Now, we will multiply cos A with the terms inside the bracket. So, this will become cos A plus cos square A divided by sin A plus sin A plus sin square A divided by cos A. Now, here we are going to rearrange the terms as cos A plus sin square A, that is the last term, are grouped together, and the middle two terms are grouped together. This will become sin A plus cos square A divided by sin A. Now, we will find out the LCM. This will become cos A into cos square A plus sin square A plus sin square A plus cos square A divided by sin A. Now, we know by the trigonometric identity that sin square theta plus cos square theta is equal to 1. So, the numerator here will become 1. This is 1 divided by cos A, and similarly here also sin square theta plus cos square theta is equal to 1. So, by the trigonometric identity, the numerator here also is equal to 1. So, this will become 1 divided by sin A, and we know that 1 by cos A is equal to sec A, and 1 by sin A is equal to cosec A, and this is equal to the right hand side, and hence we have proved the left hand side and the right side are equal. In the next part of the question, we have to prove that sin A minus cos A into 1 plus tan A plus cot A is equal to sec A divided by cosec square A minus cosec A divided by sec square A. So, here we will first write tan A and cot A in the form of sin and cos. So, this can be written as sin A minus cos A into 1 plus sin A by cos A and cos A by sin A. Now, we will multiply sin A with all the terms in the second bracket. So, this will become sin A plus sin square A by cos A, plus when we will multiply sin A with cos A divided by sin A and sin A will get cancelled, and we are left with cos A. Now, similarly, we are going to multiply minus cos A with all the terms in the second bracket. So, this will become minus cos A minus. Now, when we will multiply cos A with sin A by cos A and cos A will get cancelled, and this will give us minus sin A, and the last one will be cos square A divided by sin A. Now, here sin A and minus sin A, cos A and minus cos A will get cancelled, and this will give us sin square A by cos A minus cos square A by sin A. Now we know that 1 divided by cos A is equal to sec A. So this 1 divided by cos A can be written as sec A, and sin square A can be written in the form of 1 divided by cosec square A. So this will become cosec square A. Similarly, 1 divided by sin A can be written in the form of cosec A, and cos square A can be written as 1 divided by sec square A. Now this is because we know that sin A is the reciprocal of cosec A and cos A is the reciprocal of sec A. Now this is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. In the sixth part of the question, we have to prove that square root of sec square A plus cosec square A is equal to tan A plus cot A. So let's begin with the left hand side first. So this will become 1 divided by cos square A plus 1 divided by sin square A. Now this is because sec A is equal to 1 by cos A and cosec A is equal to 1 by sin A. Now we will find out the LCM here. So this will become sin square A into cos square A, and the numerator will become sin square A plus cos square A. Now we know that by the trigonometric identity sin square theta plus cos square theta is equal to 1, the value of the numerator will become 1. So this will become 1, and the denominator is sin square A into cos square A, and we have to find the square root of this. So square root of this is equal to 1 by sin A into cos A. Now here we will consider this as equation A. Now we will begin with right hand side, which is equal to tan A plus cot A. Now this can be written in the form of sin and cos as sin A divided by cos A plus cos A divided by sin A. Now this is because tan A is equal to sin A by cos A and cot A is equal to cos A by sin A. Now we will find out the LCM. So the denominator will become sin A into cos A, and the numerator will become sin square A plus cos square A. Now we know that by the trigonometric identity sin square theta plus cos square theta is equal to 1. The numerator here is also equal to 1. So this becomes 1 divided by sin A into cos A, and we are marking this as equation B. Now you can see from the equation A and B, it is clear that left hand side is equal to right hand side. So therefore we have proved that the left hand side and right hand side are equal from A and B, hence proved. The next part of the question is we have to prove that sin A plus cos A into sec A plus cosec A is equal to 2 plus sec A into cosec A. So here we will again begin with the left hand side. Now this can be written as sin A plus cos A into sec A can be written in the form of cos as 1 by cos A, and cosec A here can be written in the form of sin as 1 by sin A. This is because sec A is equal to 1 by cos A and cosec A is equal to 1 by sin A. Now we will multiply sin A with both the terms of the second bracket. So this will become sin A by cos A plus sin A into 1 by sin A will give us 1, as sin A and sin A will get cancelled out. Similarly, now we will multiply cos A with the terms of the second bracket. So this will become 1 plus cos A by sin A. Now this is equal to 1 plus 1, that is equal to 2. Sin A by cos A here will be grouped along with the last term of the expression. So this will become sin A by cos A plus cos A by sin A. Now we will find out the LCM of these two terms. So this will become 2 plus sin A by cos A, and the numerator will become sin square A plus cos square A. Now we know by the trigonometric identity that sin square theta plus cos square theta is equal to 1. The numerator here will become 1. So this will become 1 by sin A into cos A. Now we can write it as 1 by sin A becomes cosec A, and 1 by cos A is equal to sec A. Now this is equal to the right hand side, and hence we have proved that the left hand side and the right hand side are equal. In the next part of the question, we have to prove that tan A plus cot A into cosec A minus sin A into sec A minus cos A is equal to 1. So we will begin with the left hand side, and we will convert all the trigonometric ratios here in the form of sin and cos. So this will become sin A by cos A plus cos A by sin A. Cosec A can be written as 1 by sin A minus sin A. Sec A can be written as 1 by cos A minus cos A. Now, the LCM of the first two denominators in the first bracket is equal to sin A into cos A, and the numerator will become sin square A plus cos square A. The LCM of the second bracket is sin A, and the numerator will become 1 minus sin square A. The LCM of the third bracket is cos A, and the numerator will become 1 minus cos square A. Now here we know that sin square theta plus cos square theta is equal to 1. So the first bracket numerator will become 1. So this is 1 divided by sin A into cos A into 1 minus sin square A can be written as cos square A, as we know that sin square theta plus cos square theta is equal to 1. Therefore, 1 minus sin square theta is equal to cos square theta. So this can be written as cos square A divided by sin A, and similarly 1 minus cos square A can be written as sin square A, and the denominator will be cos A. Now here sin A and sin A will cancel sin square A in the numerator. Cos A and cos A will cancel cos square A in the numerator, and we are left with 1, and this is equal to the right hand side, and hence we have proved that the left hand side and the right hand side are equal. In the next question, we have to first prove that cot square A minus cot square B is equal to cos square A minus cos square B divided by sin square A into sin square B. And then we have to prove this is equal to cosec square A minus cosec square B. So let's begin with the left hand side, which is given as cot square A minus cot square B. Now this can be written as cos square A divided by sin square A minus cos square B divided by sin square B. This is because cot A is equal to cos A by sin A, cot B will be equal to cos B by sin B. Now we will find out the LCM here. So this will become cos square A into sin square B minus sin square A into cos square B in the numerator, and the denominator will be equal to sin square A into sin square B. Now we can write sin square B in the form of cos square as cos square A into 1 minus cos square B. This is because sin square theta plus cos square theta is equal to 1. Therefore, sin square theta will be equal to 1 minus cos square theta. And similarly, we will write sin square A here in the form of cos as 1 minus cos square A, and this is divided by the denominator, that is equal to sin square A into sin square B. Now we will open the brackets. So this will become cos square A minus cos square A into cos square B minus cos square B plus cos square A into cos square B divided by sin square A into sin square B. Now minus cos square A into cos square B will get cancelled out with plus cos square A into cos square B. So we are left with cos square A minus cos square B divided by sin square A into sin square B. Now you can see this was the middle part and we have got this. Now we will continue, and this can be now written as 1 minus sin square A minus 1 plus sin square B divided by sin square A into sin square B. This is because cos square A now can be written as 1 minus sin square A, and cos square B now can be written as 1 minus sin square B, but here we have a negative sign, so the signs will get reversed. Now this will cancel out plus 1 and minus 1, and we are left with sin square B minus sin square A in the numerator. This will be the denominator now. Now we will divide the numerator by the denominator. So this will become sin square B divided by sin square A into sin square B minus, now this numerator will be divided. This will become minus sin square A divided by sin square A to sin square B. Now sin square B will get cancelled out, and here sin square A will get cancelled out. So we are left with 1 divided by sin square A, and 1 divided by sin A is equal to cosec A. So this can be written as cosec square A minus, here we have 1 divided by sin square B, and 1 divided by sin B can be written as cosec B. So this will be minus cosec square B, and now this is equal to the right hand side, and hence we have proved that the left hand side and the right hand side are equal, and also proved that there was an intermediate step here which was equal to the left hand side. The question number 11 is, if 4 cos square A minus 3 is equal to 0 and A lies between 0 degree and 90 degree, then prove that sin 3A is equal to 3 sin A minus 4 sin cube A. So we will begin our answer with what is given to us. So this is equal to 4 cos square A minus 3 is equal to 0, and now we will rearrange it. This will become cos square A is equal to 3 by 4, and we will find out the square root of both the sides. So this will become cos A is equal to root 3 by 2, and we know that cos 30 degree is equal to root 3 by 2. So from this, the value of A is equal to 30 degrees. Now we will put it in the equation that we have to prove. So let's begin with the left hand side of the equation, which is equal to sin 3A. Now here we will put the value of A as 30 degree. So this will become sin 90 degree, and sin 90 degree is equal to 1. So this becomes our first equation. Now we will begin with the right hand side, which is equal to 3 sin A minus 4 sin cube A. Now we will put the value of sin A again as sin 30 degree. And here also it will become sin 30 degree whole cube. Now the value of sin 30 degree is equal to 1 by 2. So this will become 3 into 1 by 2 minus 4 into 1 by 2 whole cube will become 1 by 8. Here 4 and 8 will get cancelled out. This will become 3 by 2 minus 1 by 2, that is equal to 2 by 2, which is equal to 1. And from the equations A and B, we can conclude that the left hand side is equal to the right hand side, and hence we have proved. To prove the second part of the question, again we will begin with what is given to us, which is equal to 4 cos square a minus 3 is equal to 0. So this can be written as cos square a is equal to 3 by 4. So therefore cos a is equal to root 3 by 2, and we already know that cos 30 degree is equal to root 3 by 2. So therefore the value of a is equal to 30 degrees. Now we will put it in the left hand side of the question. This will become cos 3a. In place of a, we have already found the value of a, which is equal to 30 degree. This will become cos 3 into 30 degree, that is equal to cos 90 degree, and we know that cos 90 is equal to 0. So this becomes our equation first, that is a. Now we will begin with the right hand side, which is equal to 4 cos cube a minus 3 cos a. Here in place of cos a, we will write it as cos 30 degree. So this will become cos 30 degree whole cube minus 3 into cos 30 degree. Now we know the value of cos 30 degree is equal to root 3 by 2. So this will become 3 by root 3 by 8, as we have a cube over here. And the second part will become 3 into root 3 by 2. Now here 4 and 8 will get cancelled out. So this will become 3 root 3 by 2 minus 3 root 3 by 2, which is equal to 0. And this becomes our second part of the equation, that is b. Now from a and b, we can conclude that the left hand side and the right hand side are equal, and hence we have proved. The question number 12 is, find a if a lies between 0 degree and 90 degree, and the equation that is given to us is 2 cos square a minus 1 is equal to 0. So we will begin with the equation. Now we will rearrange it as 2 cos square a will be equal to 1, and cos square a can be written as 1 by 2. We'll take the square root of both the sides. This will become cos a is equal to 1 by root 2, and we know that cos 45 degree is equal to 1 by root 2. That means a is equal to 45 degrees, and this is the answer of the first part. The second equation that is given to us is sin 3a minus 1 is equal to 0. So here we can rearrange it as sin 3a will be equal to 1, and we know that sin 90 degree is equal to 1. Therefore the value of 3a is equal to 90 degree, and the value of a will be equal to 90 divided by 3. So therefore the value of a will be equal to 30 degrees, and this is the answer of the second part. The third equation that is given to us is 4 sin square a minus 3 is equal to 0. So here we can rearrange it as sin square a will be equal to 3 by 4, and we will take the square root of both the sides. So this will become root 3 by 2, and we know that sin 60 degree is equal to root 3 by 2. So therefore the value of a is equal to 60 degrees. The next equation that is given to us is cos square a minus cos a is equal to 0. So here first we will take cos a as common. So this will become cos a minus 1 in the bracket, that is equal to 0. Now either of the two expressions should be equal to 0, then only the product can be 0. So this will be equal to cos a is equal to 0 or cos a minus 1 is equal to 0. Now we know that cos 90 degree is equal to 0, and here we are going to rearrange it. So this will become cos a is equal to 1. So we know that cos 90 degree is equal to 0. Therefore, angle A will be equal to 90 degree, or here we know that cos A is equal to 1 and cos 0 is also equal to 1. So, from this we will get A is equal to 90 degree or A is equal to 0 degree. The next equation is 2 cos square A plus cos A minus 1 is equal to 0. Now here first we will write cos A as 2 cos A minus cos A. 2 cos A minus cos A will give us plus cos A, and so we are rearranging it. This will become equal to 0. Now we will take 2 cos A common from the first two terms. This will become 2 cos A into cos A plus 1 minus 1 will be taken out common from the last two terms. This will become cos A plus 1 to 0. Now we will get two brackets here, that is 2 cos A minus 1 into cos A plus 1 is equal to 0. Now either of these two expressions should be equal to 0, then only the product is equal to 0. So this means that either 2 cos A minus 1 is equal to 0 or cos A plus 1 is equal to 0. Now we will rearrange it and we can write it as cos A is equal to 1 by 2 or cos A is equal to minus 1. Now we know that cos 60 degree is equal to 1 by 2, but no value of A will, that is between 0 degree and 90 degree, will give us the answer as minus 1. So we will discard cos A is equal to minus 1, and from the first part we will conclude that therefore A is equal to 60 degrees, and this is the answer. Question number 13 is, if A lies between 0 degree and 90 degree, we have to find the value of A if the equation given is cos A divided by 1 minus sin A plus cos A divided by 1 plus sin A is equal to 4. So we will begin with the equation that is given to us. So here cos A by 1 minus sin A plus cos A by 1 plus sin A is equal to 4 is given. Now we will find out the LCM of the denominators. So it will become 1 minus sin A into 1 plus sin A, and the numerator will become cos A plus cos A sin A plus cos A minus cos A sin A is equal to 4. Now minus cos A sin A plus cos A sin A will get cancelled out, and the numerator now will become 2 cos A. The denominator is of the form A minus B into A plus B, that is equal to A square minus B square. So this will become 1 minus sin square A, that is equal to 4. Now we know that 1 minus sin square A can be written as cos square A by the trigonometric identity that sin square theta plus cos square theta is equal to 1. Therefore 1 minus sin square theta can be written as cos square theta. Now this numerator here is 2 cos A. So cos A will get cancelled out in the numerator and denominator, and we are left with 2 by cos A is equal to 4. This can be rearranged as cos A is equal to 2 by 4, which is equal to 1 by 2. And we know that cos 60 degree is equal to 1 by 2. From this we can conclude that the value of A is equal to 60 degrees. The second part of the question is sin A divided by sec A minus 1 plus sin A divided by sec A plus 1 is equal to 2. So this is the given equation and we will begin with this. Now find out the LCM. So that will become sec A minus 1 into sec A plus 1 and the numerator will become sin A to sec A plus sin A, and here sin A will get multiplied with sec A minus 1. That will give us sin A sec A minus sin A, and this is equal to 2. Now plus sin A minus sin A will get cancelled out, and we are left with 2 sin A into sec A divided by sec square A minus 1, and this is equal to 2. Now the denominator here was of the form a minus b into a plus b. So this can be written as a square minus b square, that is equal to sec square a minus 1. Now 2 is common in the numerator here and the denominator, so it will get cancelled out. Now we can write it as sin a into sec a, and the denominator here now can be written as tan square a. This is because 1 plus tan square theta is equal to sec square theta. So sec square theta minus 1 will be equal to tan square theta, and this is equal to 1. Now we can rearrange it now in the form of sine and cos. This will become sin A. Sec A can be written as 1 by cos A, and tan square A here can be written as sin square A and cos square A in the numerator now. So sin A will get cancelled out with this sin A, cos A will get cancelled out with this cos A, and this is equal to 1. And we know that cos A and sin A, only these two terms are left. This will become cot A is equal to 1, and we know cot 45 degree is equal to 1. Therefore, value of angle A will be equal to 45 degree. The question number 14 is, prove that cosec A minus sin A into sec A minus cos A into sec square A is equal to tan A. So we will begin with the left hand side. Now we can write it as 1 by sin A minus sin A into 1 by cos A minus cos A into 1 by cos square A. This is because cosec A is equal to 1 by sin A, sec A is equal to 1 by cos A, and sec square A can be written as 1 by cos square A. Now we will find out the LCM. So this will become sin A. The numerator will become 1 minus sin square A. The second bracket will become 1 minus cos square A, and the denominator here is cos square A. Now we know by the trigonometric identity that sin square theta plus cos square theta is equal to 1. 1 minus sin square A can be written as cos square A. Similarly, 1 minus cos square A can be written as sin square A. Now cos square A here will get cancelled out with cos square A. Sin A will get cancelled out with this sin A, and we are left with sin A divided by cos A. This is equal to tan A, and this is equal to the right hand side, and hence we have proved that the left hand side and the right hand side are equal. The 15th question is, prove the identity sin theta plus cos theta into tan theta plus cot theta is equal to sec theta plus cosec theta. So we will begin from the left hand side. Now this can be written as sin theta plus cos theta. Tan theta can be written as sin theta by cos theta, and cot theta can be written as cos theta by sin theta. Now we will find out the LCM of the denominators in the second bracket. So this will become sin theta into cos theta, and the numerators will become sin square theta plus cos square theta. Now we know by trigonometric identity that sin square theta plus cos square theta is equal to 1. So we are left with sin theta plus cos theta multiplied by 1 by sin theta into cos theta. Now we will divide the numerators individually by the denominator. So this can be written as sin theta divided by sin theta cos theta plus cos theta divided by sin theta cos theta. Here sin theta will get cancelled out. Here cos theta will get cancelled. We are left with 1 by cos theta, that can be written as sec theta, and here it is 1 by sin theta, which can be written as cosec theta, and this is equal to the right hand side, and hence we have proved that the left hand side and the right hand side is equal.